In the previous session, we looked at symmetric functions. Let's look at some examples of symmetric functions. So let's look at sigma alpha square for a cubic polynomial. Now remember the sigma notation. So here there are two aspects. One is the cubic polynomial is the context, which means there are going to be three roots. And when we say sigma alpha square, what we mean is alpha square plus beta square plus gamma square. Okay, so we have to figure out an expression for sigma alpha square in terms of the coefficients of the cubic polynomial. So let's see how we can figure out that. We know sigma of alpha is equal to alpha plus beta plus gamma because there are three roots to the cubic polynomial equation. Now let's square both the sides. We get sigma alpha square is equal to alpha plus beta plus gamma square. Now expanding this, what do we get? We get alpha square plus beta square plus gamma square plus 2 alpha beta plus 2 beta gamma plus 2 gamma alpha. Alpha square plus beta square plus gamma square is nothing but, in sigma notation, sigma alpha square. And these three terms, 2 alpha beta plus 2 beta gamma plus 2 gamma alpha, can be written as 2 times sigma alpha beta. Now here, immediately you recognize that we have to figure out sigma alpha square. Keeping that in mind, let's see how we can simplify it. We have sigma alpha square. Now sigma alpha itself, we know alpha plus beta plus gamma is equal to minus b by a. So minus b by a square is equal to sigma alpha square plus 2 times, and sigma alpha beta we know is c by a. So we do the substitutions. Now let's rearrange this. We get sigma alpha square is equal to minus b by a the whole square minus 2c by a. So what have we achieved here? We have written sigma alpha square in terms of the coefficients of the cubic polynomial equation. Okay, now let's look at the next one. Sigma alpha cube for a cubic polynomial. I think you've got the idea now. So we have ax cube plus bx square plus cx plus d equal to 0. Let's assume alpha, beta, gamma are the roots. Each root satisfies the equation. So which means we can substitute these roots into the equation. So we have a alpha cube plus b alpha square plus c alpha plus d equal to 0. Now substituting beta, we get a beta cube plus b beta square plus c beta plus d equal to 0. So we are substituting these roots into the equation. So a gamma cube plus b gamma square plus c gamma plus d equal to 0. Now let's add up these three equations. Now why are we adding up these three equations? Because somehow we want alpha cube plus beta cube plus gamma cube, which is what sigma alpha cube is. We get a times, because a is common, alpha cube plus beta cube plus gamma cube plus b is common. So b times alpha square plus beta square plus gamma square plus c times alpha plus beta plus gamma plus 3d equal to 0. Now this can be written as a times sigma alpha cube plus b times sigma alpha square plus c times sigma alpha plus 3d equal to 0. Now we know sigma alpha square, we just now derived it. A times sigma alpha cube is equal to minus b times sigma alpha square minus C times sigma alpha minus 3D. Now what has happened here? What we are doing is we are bringing A times sigma alpha cube to one side. So the second terms becomes minus B times sigma alpha square when we bring it to the other side. Similarly, minus C times sigma alpha minus D. Now we bring this A to the other side by dividing both sides by A. Since sigma alpha is equal to minus B by A and sigma alpha square is equal to minus B by A the whole square minus 2 times C by A, let's do the substitutions. We get sigma alpha cube is equal to minus B times minus B by A the whole square minus 2C by A minus C times sigma alpha, which is minus B by A, and minus 3D divided by A. Now it's just a question of simplifying. Minus B times minus will disappear because of the square. So B square by A square minus 2C by A plus, because minus minus, plus BC by A minus 3D, the whole thing divided by A. Minus B also we take it inside, we get minus B cube by A square plus 2BC by A plus BC by A minus 3D, the whole thing divided by A. Now let's combine all these terms. We get minus B cube plus 2ABC plus ABC minus 3A square D. The whole thing divided by A square in turn divided by A. Now let's simplify this. A square times A is A cube. So we get sigma alpha cube is equal to minus B cube plus 3ABC minus 3A square D divided by A cube. So that was sigma alpha cube in terms of the coefficients of the cubic polynomial. Now let's look at the next one. Now let's look at figuring out sigma alpha square beta for three roots, alpha, beta, and gamma. So again, we are given the context. Sigma alpha square beta can be written in the expanded form as alpha square beta plus beta square gamma plus gamma square alpha plus alpha square gamma plus beta square alpha plus gamma square beta. Now let us factor the RHS. We get alpha times alpha beta plus beta times beta gamma plus gamma times gamma alpha plus alpha times alpha gamma plus beta times beta alpha plus gamma times gamma beta. Now again, let's see commonalities. We have alpha times alpha beta. So alpha times alpha gamma is there here. So alpha is common to both. Actually, alpha square is common, but let's stick to this factorization that we have done of each term. So alpha times alpha beta plus alpha gamma plus beta times beta gamma plus beta alpha plus gamma times gamma alpha plus gamma beta. Now let's factor inside the brackets. We get alpha square, because alpha is common to both the terms inside the bracket. So alpha square times beta plus gamma plus beta square times gamma plus alpha plus gamma square times alpha plus beta. Alpha square times, remember we know alpha plus beta plus gamma. Just beta plus gamma we don't know. So let's add alpha, which means we have to also subtract. So we have beta plus gamma plus alpha minus alpha. Similarly here, gamma and alpha is there, beta is not there. So let's add and subtract beta. Similarly here, we don't have gamma. So let's add and subtract gamma. So we end up with alpha squared times beta plus gamma plus alpha minus alpha plus beta squared times gamma plus alpha plus beta minus beta plus gamma squared times alpha plus beta plus gamma minus gamma. We know alpha plus beta plus gamma is sigma alpha. Basically, writing the same thing in sigma notation. Minus alpha plus beta square times, again, sigma alpha minus beta plus gamma square times sigma alpha minus gamma. Let's open up the brackets, the square brackets. Alpha square times sigma alpha minus alpha cube. Alpha square times alpha cube, plus beta square times sigma alpha minus beta cube, plus gamma square times sigma alpha minus gamma cube. Alpha square times sigma alpha plus beta square sigma alpha plus gamma square sigma alpha minus, see, we have minus alpha square cube minus beta cube minus gamma cube. So we take minus common out and we have alpha cube plus beta cube plus gamma cube. So now, which means this can be written as alpha times alpha square plus beta square plus gamma square. Why? Because here sigma alpha is common to all the three. Minus alpha cube plus beta cube plus gamma cube. So we have sigma alpha times, this is nothing but sigma alpha square minus, this is nothing but sigma alpha cube. So we have already seen that sigma alpha is minus b by a. Sigma alpha square is equal to minus b by a the whole square minus 2c by a. And we know that sigma alpha cube is equal to minus b cube plus 3abc minus 3a square d divided by a cube. So now we do the substitutions. Where do we do the substitutions? Here we have sigma alpha, which is minus b by a, times sigma alpha square, which is minus b by a the whole square minus 2c by a, minus sigma alpha cube, which is minus b cube plus 3abc minus 3a square d divided by a cube. Now simplification. This becomes b square by a square times minus b by a gives us minus b cube divided by a cube, plus minus times minus plus 2bc divided by a square minus b cube plus 3abc minus 3a square d divided by a cube. Now let's combine all this. We get minus b cube plus 2abc plus b cube minus 3abc plus 3a square d divided by a cube. Simplifying it, because 2abc minus 3abc gives us minus abc plus 3a square d divided by a cube. So here minus b cube plus b cube gets cancelled out. Now let's factor out a is common to both of them. In the numerator, we take it out and cancel it with one of the a's in the denominator. We get 3ad minus bc divided by a square. And again splitting it, we get 3d by a minus bc by a square. So we have found sigma alpha square beta in terms of the coefficients of the polynomial equation, specifically cubic polynomial equation. That's it for now. Bye.